I really appreciate China Oxford Scholarship Funding giving such a great opportunity to, can you hear me? Such a great opportunity to this academic phase, and thank you very much, Bolton, for your very kind research, a very kind introduction. A brief background about my research. I'm looking at the metal circulation in Shang Dynasty. Here is a chronology of Chinese history, giving an idea when Shang Dynasty is. It ranges from 16th century BC to 11th century BC, and it is basically 1,000 years earlier than Qin Dynasty. So we are very lucky that we uncovered its capital city, which is called Yinxu or Yinxu site, if you like. The broader area is called Central Plain, and in Central Plain area, we uncovered a we uncovered thousands of metal alloys from the red square. You can see that this unique animal face is called tall tip, which is considered often as the symbol of central polity in late Shang China. And the overall research question here is where metal came from. Why is this question interesting to us? Because as the most productive workshop throughout Eurasia in late Bronze Age, Central Plain is just precisely and strikingly located in the most copper poor area. As you can see from this map, most copper mines are located outside Central Plain. So basically, people in Central Plain don't have very good access to copper mine. So this huge imbalance between raw material and production center encourages scholars to further investigate the provenance of copper. One of the most commonly used methods is to follow inscriptions on the metals. Historians would argue that based on the inscriptions, the copper utilized in Central Plain should be sourced back to the middle and the lower Yangtze River. The problem of this research is that most inscriptions utilized by historians are much later. So inscriptions here are the second-hand evidence rather than direct evidence. The other method we often rely upon is called lead isotope. For those who are not familiar with this technique, you can understand lead isotope as a chemical signature we can analyze in the objects. And according to the research conducted by Chinese and Japanese scholars, they found that the source of copper utilized in late Shang should be traced back to southwestern part of China, which is completely different from the argument proposed by the historians. Their main evidence is attributed to this highly radiogenic lead isotope. By highly radiogenic lead isotope, it means that lead isotope 207 by lead isotope 206 is below 0.78. However, this argument is also problematic for two reasons. The first reason is that we are talking about 1,500 miles from southwestern part of China and the central party. Can Asian people really travel that far? And the second thing is that, as you may know, most Asian Chinese copper alloys are leaded. So lead isotope here is a trace of lead rather than trace of copper. What I'm trying to do is to investigate this problem from another point of view. The method here is basically follow the paper published by Dr. Peter Bray and Professor Mark Pollard here in Oxford. The main argument is that chemistry object is not stable. According to simulation experiments and thermodynamics, arsenic and antimony would drop off in remelting and recycling. By contrast, silver and nickel would increase relatively. So we suggest that the overall assemblage of copper throughout Eurasia should be divided into 1 to 16 groups based on the presence and absence of 4 diagnostic elements: arsenic, antimony, silver, and nickel. So here is the 1 to 16 groups. For example, group 1, N, which means no, 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 no. No arsenic, no antimony, no silver, and no nickel in this object. So the other way around for group 16, yes, 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 yes. There is arsenic, antimony, silver, and nickel in this object. So each object could be uniquely attributed to one of the 16 groups. Here is the starting point of my research. All the plots are from central plane objects. As you can see very easily, simply by plotting the lead isotope against our new idea, copper groups, a very interesting pattern occurs to us. Group 1 and Group 2 are particularly associated with lead isotope 1, lead isotope A, and Group 12 is particularly associated with lead isotope B. What does this pattern mean? What is archaeology behind? The argument here is, to understand this pattern, we need to zoom out, to put this whole graph into a wide context. So what I mean is that enough has been done in central plane. Now we need to escape from central plane to go to periphery areas to find out what kind of metal in periphery areas is used. The first periphery area I'm going to present to you is called Hanzhong site. And I also, in the map, labeled modern Xi'an to give you an idea where geographically Hanzhong is, and the terracotta warriors, if you like. A couple of hundreds of objects have been found in Hanzhong. A majority of vessels are typologically related to central plane. As you can see, the right one is from central plane, and the left one is from Hanzhong. They are so similar to each other. And also in Hanzhong, we have uncovered this kind of peculiar stuff, which are often considered as local produced objects. So the question here is, since Hanzhong and central plane are related in terms of typology, how about chemistry? Here is the result of chemistry. A wide range of chemistry has been recorded in Middle Shang Hanzhong. You can see that group 1, group 2, group 4, group 9, probably group 11, and group 16 are extremely wide range of chemistry. However, when it stepped into late Shang, the interesting thing happened. All the other groups suddenly disappeared, and only group 1 survived with extremely high proportion. What happened to this site, and what is archaeology behind? Same argument, we need to zoom out to put this pattern into a wide context, a wide time space. Before doing that, I need to explain the legend here. If an area is labeled by red point, it means that, for instance, in this area we analyzed 100 objects. Over 50 of them are attributed to no group. So here, the color means the proportion of single copper group rather than concentration of single element. MS means Middle Shang. Off we go. This is Middle Shang, central plane. 40% of overall assemblage are attributed to no group. Nothing interesting. And here is another site in Middle and Lower Yangtze River, and nothing interesting at all. Slightly later, but also in Middle Shang, we have our Hanzhong. You can see the pattern, if you see clearly. The pattern, the decoration pattern is slightly changed, but it is still in Middle Shang. Nothing interesting in Middle Shang. However, what we think is interesting is in late Shang. Not only Hanzhong, but also the other side called Sanxingdui. In both sides, we have this extremely high proportion of no. And this proportion of no drops a bit into central plane and drops a bit again further east. So here we have a very nice metal flow from west to east. And in the very beginning, if you remember, group 1 and group 2 are particularly associated with lead isotope A, and group 12 is particularly associated with the other lead isotope. Here is a pattern of group 12. Amazingly beautiful metal flow from east to west. So here, the overall picture is, I often use the analogy of hotpot to describe the Shang people collecting metals from everywhere and get them home. And so, here is the details. We have two movements of metal, one from north, one from west, and one from east, and went into central plain. What I really want to point out is that metal network is only a small respect in this overall social network. Not only in central plain, but also in a wide range of periphery areas. We also have this constantly encountered tall tier decoration system. It means that metal network provides a good platform on which people get involved, get communicate with each other, and enrich their own ways of doing things. So that is the whole point of this research. While collecting coppers, some people get their own ideas shared as well, and it is widely accepted by local periphery people as well. So as I came to my close, I would like to share with you two of my favorite quotes. One can resist the invasion of an army, one cannot resist the invasion of ideas. Archaeology is about humans, it is not about stuff. I thank you all very much.
So we have some time for questions.
Before the question part, could I point out that Professor Mark Pollard is just sitting in the back. So he is the right person to ask a question to. I'm not really responsible.
So welcome, Professor Pollard. And so please, questions.
Thank you for your talk. It was really interesting because from a genetics point of view, you can do the same with humans as you can do with pots and see where they're from. But of course with humans you can take blood samples and do DNA testing. So how do you test these precious ancient relics? Do you have to take a sample?
I'm looking at the metals, so actually I'm not dealing with bones. So, but I do think that in the research lab of Oxford, they are going to have a genetic study center which can do this.
So I guess you try to date the metal by taking a sample from the metal objects, right?
That's right. Sometimes it is non-destructive technique, sometimes it is destructive technique. We need to draw something, cut off something, and measure it down and analyze it.
In your analysis, do you have problems in obtaining the objects that you want to analyse? Are these objects obtained from Oxford museums, for example, or from UK museums, or are they obtained from museums in China? And presumably the analysis is done in Oxford.
Actually, at this stage, all of our data are coming from published database. So we haven't done our own analysis, but we are going to do a more analysis. Here the assumption is that the more data we have, the more clear metal movement we have. And yes, it's a very good question that due to conservation perspective, it is very difficult to get access to the museum objects. But as you can see, this method is based on the qualitative process. So often we use non-destructive analysis, so it is allowed.
Thank you.
So maybe one more question if there's any.